Hey guys, welcome to another video, another Leetcode solving video. Today we're looking at Leetcode 2349 and it's today's daily challenge, I guess. And it is designing a number container system. So we're told that we need to design a number container system that can do the following. Insert or replace a number at the given index in the system and return the smallest index for the given number in the system. So we need to implement a number containers class. The number containers, just calling number containers will initialize the container system. Then we've got two methods, two functions. Change, which is a void function, so it doesn't return anything, but we are passed in an index and a number, both integers, and we need to fill the container at the index with the number that we're given. But if there is already a number at that index, we need to replace it. And the last or the second method is find, and this does return it gives the index the smallest index, so we need to return the smallest index for the number that we're given, or -1 if there is no index that is filled by a number in the system. So if we don't find any number, then we just return -1. If we do, we return the index but the smallest index. But we know we've seen a couple of times they say the smallest index return a container system that can return the smallest index, so we already know that there's something about a sorted list going on here. So we need to somehow figure out how we can find the smallest index using a sorted list. So that's a bit of a giveaway. And here we're given the potential inputs for one of the test cases, and then a bit of an explanation, a bit of a write-up going on here, and then the output. So, and also we're given some constraints. So these are some basic constraints. So yeah, let's code this up in Python, and I've already coded this up in Python, so I'll walk through the solution. So what we want to do first is we want to import sorted list. So there's a couple of ways you can do this. You can do your own, if you want to be fancy, do your own sorting function. But to make things simple, we can import sorted list from sorted containers, which is a built-in Python library. And since the first thing that's going to happen is we're going to be the program Leetcode will basically initialize our number containers. So we need an init function, and in this init function, we need to set two data structures. So the first one, as you would imagine, is quite simple: insert or replace a number at the given index. So for that, we can just use a hash map, basic dictionary. But we also know that we need to return the smallest index for a given number in the system, and like I said before, the giveaway is smallest index, and so we need a sorted list for that, and so we can use our sorted list that we've imported. So we'll have two data structures that we'll need to maintain: the hash map as well as the sorted list. And I mean, technically we could just use one, but for simplicity and for speed and performance, it makes sense to use both. So the first function is change. So this is a void function. However, we are given an index and a number. So if we just skip this part and we just look at these two lines first, well, it's quite simple. We just say, let's set the index value in our hash map to our number, and then let's set our sorted list. Let's add the number. Let's give a number and then add the index as well. So at the index, we will add this number that we're given in. However, in the case that the index already exists in our hash map, well, we need to remove it, from our sorted list. So we can store the number at the previous index and then remove it from our sorted list. So you can see we're simultaneously maintaining both data structures, our lookup dictionary and our sorted list. Now let's look at our find function. So our find function is kind of similar, but one thing I want to mention is when we're returning sorted list, so when we look up the number in our sorted list, you can see we're using 0 here, and that's because sorted list does not just return the first index, it will return a bunch of indexes. So for example, let's say we've got 3 5s in our number, so in our sorted list, and we're told we need to find 5. Well, we'll get all indexes for the number 5, but we want to return the smallest index, so that would be the 0th index or the first index. So as a guard function, well, as a guard statement, what we put here is we say if number not in self-sorted list, so if the number does not exist in the sorted list, or the number, or the sorted, or the number of values, when we look up this number, the number of indexes is 0, then we just return -1 like we're told here. Otherwise, we return the number, or the smallest index of our number. So yeah, let's run our test cases. And we can see we've only got one test case, and that passes just fine. And submitting our solution, and there we go. We have quite an optimal solution, quite a basic and simple solution. And again, there are ways that we could, if you want to impress an interviewer, you can maybe implement your own sorting, bubble sort or something, some sort of merge sort, some sort of sorting algorithm of your own, and that would definitely be bonus points. But for the purpose of this question, we can definitely just import the sorted list data structure. So yeah, thanks for watching, guys. Stay tuned for more videos and for more walkthroughs. Thank you, and bye.